Hello everyone, welcome to the India's largest e-learning platform. How are you guys? कैसे हैं आप लोग? Everyone, come fast. एक बार जल्दी जल्दी आ जाओ बेटा. And everything is fine. Audio, video, please confirm. Komal, good afternoon. एक बार जल्दी से आ जाओ बेटा. Because it is a very very important session. Because in this particular session we are going to discuss about the flip-flops. And the few, if we'll get the time, then we'll start the counter also. Otherwise, I'll take the counter into the some different in different session, right? So everyone come fast. Very important session. Okay, my dear friend, everyone. Before going to start this session, I just want to share some information about myself. My name is Chandan Jha. 10 plus years of teaching experience. I have cracked the ISRO exam. I have done my masters in the communication and network. Apart from the teaching, I'm also taking the motivational session. I have already taken more than 200 motivational session in various engineering college, including NITs and some of the IITs also. Sirsha, Amruta, Komal, right? Gitarni, Chin, right? Okay. Archana, good afternoon. One thing more, guys. Already you know that the Gradeup already launched the Gear Up, a concept building course for especially for the third year student. Rank Up for the final year student who have already the concept is strong and want to more practice. Apart from this Vision 2022, and apart from this one course also we have launched. That course is Ravi. That course is called Masters MSQ. If you want to need the more practice of the MSQ type question, you can attend those one also. Okay. One thing more, this is our star faculty, Rakesh Talreja sir, Dheeraj Sardana sir. This is the different branches faculty. In the EC, the Rakesh Talreja sir, me Chandan Jha sir, Sanjay Rathi sir, MN Ramesh sir, Ankit Joshi sir. These are the faculty who is going to take care, right? Swati. And this is our result, my dear friend. 20 plus student already scored under 100, right? Okay, 60 plus students, sorry. One thing more, now the Gradeup will become Gradeup Super. Sir, what should be the meaning of Gradeup Super? Gradeup Super means you are able to attend the live structured course which is provided by the Gradeup. Apart from this, you are able to access the green card also. Green card means nothing, it is just a test series, you can say that. And one thing more, every question is basically designed by the toppers. And here the India's best faculty is going to take care of your subject. Amit, Swati, Nidhi. Okay. Sir, what should be the charges for the 6 month? 12,000. For the 12 month, 16,800. And for the 24 month, 24,000. Okay, now my dear friend, now we are going to start the session, right? Sir, what is the good specialization for the CSE? Computer science in the MECTIC. Papu, there will be the lots of branches are there. You can choose according to your choice, right? Some of the people are basically in the cloud computing, they are facing very good, right? Some of in the data management, they are saying, right? So there will be the separate topic. It's totally your choice, right? Okay. वो पढ़ो जिसमें interest आए, बस. Okay. Now everyone. SR flip-flop. Now, what should be the meaning of SR flip-flop? Everyone try to understand. SR flip-flop, set reset flip-flop. This is the block diagram. Already we have discussed about the circuit diagram, right, of SR latch, and that circuit diagram of the SR latch is nothing. It is just like this. We have already discussed. This is called SR latch. We have already in the previous session we have discussed about. It is called S. It is called R, right? राहुल सर मैं ग्रीन कार्ड परचेज किए हैं लेकिन टेस्ट कहाँ दे समझ नहीं आ रहा है, प्लीज गाइड मी. ओके राहुल, राहुल आप अपना नंबर एक बार ड्रॉप कर दीजिए यहीं पे, हमारी टीम आपको कांटेक्ट करेगी एंड दे विल गाइड यू इन द प्रॉपर मैनर, राइट? Okay, now one thing more, it is already we have discussed, it is nothing, it is just a latch. It is just a latch. And now my dear friend, everybody try to understand. Sir, the latches with the control input are called flip-flop. So this one is called latch, what we have discussed. And according to that, we have to make the one controlling circuit. This is nothing, these two things are basically used for the control that input. Whatever the output is basically given, that for the controlling, we are using these two things, right? Sir, how we are going to control it, we will discuss those two. But at this particular moment, we can say that, okay, sir, latches with the control input are called nothing, it is just a flip-flop. Now, my dear friend, this is called clock, ye ho gaya clock, it is called S, it is called R. Now, sir, how the truth table will work for this particular? Yes, Rahul Kala, that's great. Rahul, okay. It is called S, it is called R. Now, everyone try to understand, sir, how we can do it. how the truth table we can form. So if you want to discuss about the truth table, my dear friend, we can say simply what we have learned into the previous session. We are going to utilize those concepts on this particular to formation of the table of this particular circuit. So how we can do it? Suppose the first, but you can feel this circuit will be operated only when the clock is applied. If you are not applying the clock, that circuit is not going to utilize, or that circuit is not going to operate. So मेरे प्यारे दोस्तों, my dear friend, this the first condition, it means here we have to provide 1, then only this circuit is going to be operate. Now in the first condition, if I'm taking S equal to 0, R equal to 0, come on, S equal to 0, R equal to 0. Sir, how we can form? How we can make the table? If S equal to 0 and R equal to 0, the meaning of this one is, sir, in the SR flip-flop, when we know that for the NAND gate, whenever the any input is low, the output will be always high irrespective of the other terminal. So if you'll apply 0, definitely, because it is a logic of the NAND gate, whenever the any input is low, the output should be high irrespective of the other terminal. So this one is 0. So definitely we can say that this will become 1. That is the NAND gate. Already we have discussed into the previous session. Suman, and sorry for inconvenience of the previous 2 sessions due to the internet issue or some personal reason. I haven't taken that class. That's why I have made that class at 12 o'clock. Right? Uske compensation mein beta. Okay. Here it is also 0. So in the NAND gate, whenever the any input is low, the output should be high. So it is 0. So of course we are getting 1. Sir, we do not have any idea about what should be the condition for 1. We do not have any idea about what should be the condition for 1. So my dear friend, everybody try to understand. For we know that for the NAND gate, Suman bhai, hello. We know that whenever the any input is low, the output we can make high. But what happened when the input is high? Sir, we are not able to comment. So my dear friend, we know that here it is called Qn bar. So it is called Qn bar. Here it is called Q1. So this is called AND gate. In the output there will be the bubble, so it will become NAND gate. So we can write it will become 1 dot Qn bar, and 1 dot Qn bar is called Qn bar, and the output there will be the bubble, so this will become nothing, it is just a Qn. It means now you are getting nothing, it is just a Qn, plus 1 is nothing, it is just a Qn. Very simple. Okay, if this one, if you write, it will become 1 dot Qn. 1 dot Qn is called Qn, and the output there will be the bubble, so it will become nothing, it is just a Qn bar. Qn bar. बहुत बढ़िया. It means the next state also hold whatever the condition is of the previous state. The meaning of this state, this situation is. Now, sir, what happened when S equal to 0, R equal? Now it will become very simple. अब तो बेटा चौन्नी भर के concept बन गए. How? Look at this one. Okay. Now everyone, sir, if the next condition, if you discuss the S equal to 0, R equal to 1. S equal to 0, R equal to 1. Sir, S equal to 0 means what should be the meaning of this? Sir, it is called NAND gate. NAND, in the NAND, whenever the any input is low, the output should be always high. So this will become high. 1, 1, so this will become low. And we know that for the NAND gate, whenever the any input is low, the output should be high irrespective of the other terminal. एक terminal हो गया 0, कोई फर्क नहीं पड़ता यहाँ क्या लगा है. Output you will get 1. And if this will become 1, here it is 1. Due to the 1, 1, it will become 0. Very simple. Bhanu Prakash, 3 hours marathon session so that we can complete the class quickly because of the link previous class. Okay, Bhanu, I know that I have already apologized for that things, but don't worry. In the future, it will not happen, and we are going to take care whatever the schedule we have provided. We are going to cover the entire course, what we have committed, 65 plus, right? Before 15th of January, believe me. Right, we have already planned according to that. That is in the free series, right? And one surprise also for you guys. One surprise is also for you. Okay. Now S equal to, so this will become nothing. It is just called 0. That's why it will become 0. Output ka 0 hona means nothing. It is just a reset. Output ka 0 hona means nothing. It is, you can say that it is a reset. Now the next condition is called what? The next condition, you can say that S will become nothing, it is just a 1, and R will become 0. If S will become 1 and R will become 0, what should be the meaning of this? Sir, 1, 1 means definitely it will become 0. Sir, 1, 0, whenever the any input is low, the output should be always high irrespective of the other terminal. Now we know that everyone, this one will become 0. so this will become 1, and if this will become 1, so here it is a 1, and 1 1, so this will become 0. That's why the qn plus 1, now it will become 1. 1 means nothing, it is just a set. It means if you are pressing the button of, okay, no issues. Now the next one, उस स्टेटमेंट को इस लास्ट टेबल के बाद बताता हूं. Okay, now if you want to discuss the next one, everyone. Yes, Mayur, yes. Now if you want to discuss the next one, that is called s equal to 1 r equal to 1. Sir, s equal to 1 r equal to 1, s equal to 1 r equal to 1, the what should be the meaning of this, everyone? Sir, 1 1 means nothing, it is just a 0. 1 1 means nothing, it is just a 0. And we know that whenever in the any input, come on, in the NAND gate, whenever the any input is low, the output should be always high, high, high. So ye bhi high, ye bhi high. Sir, how it is possible, sir? If it is a qn, it is a qn bar, so it is not possible to make the both output 1. It is not possible to make the both output 1. So my dear friend, we can say that it is an invalid condition. So you can write the invalid condition, you can write the forbidden state. Forbidden, you can write don't care. It's your choice what condition you are using. So you can feel when both is unused, s equal to 0, both if you are applying the 0 low, then you can say that it will hold the previous state. S bole to set, R bole to reset. So if you are enabling the reset, the output will become reset. If you are enabling the set, S1 R0 means you are enabling the set. If you are enabling the set, the output is set. And if both enable and disable, both if you are applying the both circuit, if you are applying the both circuit, you can feel both circuit 1 1 you can apply. Then you can say, of course, how it will become or set or reset simultaneously. That's why we can say that it is nothing, it is just an invalid state. Okay, and now everyone, one thing more, right? This is the table right now. Okay, if this condition is basically done, then my dear friend, it is called truth table. It is called nothing, it is just a what? Circuit diagram and the truth table. Now we are going to discuss about the characteristic table. Suchitra, I will send you, no issues. Suchitra, I will send you. Now it is called characteristic, everyone. This one is called characteristic table. This is called characteristic table. Sir, what should be the meaning of characteristic table, everyone? The meaning of the characteristic table means the input is known to you and the previous state is known to you. Input is known to you and the previous state is known to you, but we do not have the idea about the present state, that is called qn plus 1. So the formation of the table, come on. So the formation of the table for the qn plus 1. So come on, the formation of the table for the qn plus 1 is nothing, it is just called what? It is just called, you can say that it is called excitation, it is called characteristic table. How we can form the characteristic table, everyone? Okay, sir, if you want to discuss about the characteristic table, we can write, okay, sir, if three quantities known to you, S, R and Qn, these three quantities known to you, then how many conditions are possible? So total 8 conditions are possible. 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. These 8 conditions are possible. Now, if S equal to 0, R equal to 0 and the previous, sir, these two conditions means the S and R both are in the same condition, that is called 0. So both are 0. So we have to hold the previous state. Previous state is 0, so present state is also 0. Previous state is 1, so present state is 1. Now, the next one. Sir, S equal to 0, R equal to 1. S equal to 0, R equal to 1 means we are resetting the input. It means irrespective of the previous state, if you are reset the output, the present state should be 0. That's why in these two cases you can feel the present state is 0. Yes, yes, Chinmay. Yes, Chinmay, mere bhai. Okay. Now, if the next one, if you want to discuss S equal to 1, R equal to 0. Sir, S equal to 1, R equal to 0 is a condition where we want to, S equal to 1 means set the output. Set the output means you have to make the output 1. So my dear friend, we are making the output 1. You can feel irrespective of the previous state. अब यहां पर क्या है, इससे कोई लेना देना नहीं. आपने सेट किया, ऑन का पंखा दबाओगे बटन तो पंखा ऑन होगा, कोई फर्क नहीं पड़ता पहले क्या कंडीशन था. बटन को ऑफ करोगे, स्विच को ऑफ करोगे तो पंखा ऑफ होगा, कोई फर्क नहीं पड़ता पहले क्या था. राइट, लाइक दिस. एंड नाउ अगर ऑन और ऑफ जो बचपन में करते थे ना, ऑन ऑफ, इफ ऑन ऑफ दोनों के बटन को एक साथ प्रेस करोगे, ये हो जाएगा कंफ्यूज. राइट, दिस इज कॉल्ड नथिंग, इनवैलिड स्टेट. It is not possible. That's what it is called character. So characters table is nothing, it is just a extension of nothing, truth table. So it is a circuit diagram, it is called, it is circuit diagram, it is the truth table, it is the characteristic table. Now we are moving on the next. So now the excitation table. Sir, what happened into the on what is the basically known quantity for the excite? But before going to the excitation table, I just want to write the characteristic equation of the SR flip-flop. If you want to write the characteristic equation of the SR flip-flop, I am directly writing. But you can make it by the truth table, or you can solve by the K-map also. Because if the table is given, with the help of table, you can write the equation also. I am writing that equation directly, right? Qn plus 1 is nothing, it is just a S plus R bar Qn. S plus R bar Qn is nothing, it is just called what? It is called characteristic equation. It is called characteristic table. It is called characteristic equation. And now it's time to discuss about. Yes, Bhanu, definitely. Now the next one I'm going to discuss about the excitation table. Now I'm going to discuss about the excitation table. Everyone. Sir, for the excitation table, if you want to discuss, everyone. Sir, for the excitation table, we know the previous state and we know the present state. We know the previous state and we know the present state, right? We know the previous state and we know the present state, but we do not have any idea about the inputs, right? We know the previous state, we know the present state, but we do not have any idea about what? We do not have any idea about the input. So the formation of the table, for the input with the help of previous and present state, is called excitation table. It means by the help of excitation table, we are going to understood how the input is basically excited, or how the input excited that the state, how the state is going to change with the help of the input. That's what basically excitation table is. How we can form the excitation table, try to understand, guys. If you want to make the excitation table, how we can make? Try to understand. Sir, in the first condition, it is called Qn and it is called Qn plus 1. It is called previous state, it is called present state. So my dear friend, it is called previous, it is called present. So I am writing previous state is 0, 0. So previous is 0, present is 0. It means the transition is going from 0 to 0. Dekho. Previous is also 0, present is 0. Look at into the characteristic table. Dhyan se samajhna beta. Everyone try to understand very carefully. Look at this function characteristic table. How the transition will happen from 0 to 0. So this is happen at this place. Previous state is 0, present state is 0. There will be the one condition also. Where? In this case. The previous state is 0 and present state is 0. So my dear friend, we can say that, Payal, good morning. So previous and present both are basically 0. So we can say that, everyone. So we can say that, look at this input. What should be the condition for that? These two things. S0, R0, S0, R1. It means S is 0, S is 0. Okay, S is 0, S is 0. But if you follow R0, R1, it means it is the short that S is not going to change. But R is going to change, because R is 0 and R will become 1 when the transition will happen from 0 to 0 and 0 to 1. So we can write, so 0 to 0 means nothing. It is just a fixed S is 0. But R may be 0, maybe 1. R may be 0, maybe 1. Now we are going to discuss the next one. Okay. Now everyone try to understand. And in the today's session, we are going to discuss about the race around condition also, right? Lots of people ask to me, sir, what happened to what is the race around condition? And lots of people get confused into the race around condition. So in the today's session, we are going to discuss about the race around condition also, which generally happen into the JK flip-flop. I'm going to discuss, right? Okay. Okay. Now everyone. Sir, if you want to discuss about the 0 now, the second condition if you want to write, sir, transition will happen 0 to 0, it will become 0 to 1. So next state is 0 to 1. 0 to 1. So पहले 0 था, अब 1 है. पहले 0 था, अब 1 था. It means first 0 and after that it will become 1. This will happen in this condition. There will be the one more state? No. Only one state is there and one condition is there in which the previous state is 0 and the present state will become 1. What is that condition? Sir, this is condition. S equal to 1, R equal to 0. So I'm writing S equal to 1, R equal to 0. And now for the next one, if you want to discuss. So next one, 1 to 0 transition. 1 to 0 transition. 1 to 0 transition is happen in this case. There will be the one, no. Only one condition is happened where the transition will happen from 1 to 0. And now the transition will happen from 1 to 0. What should be the meaning of this? Sir, S equal to 0, R equal to 1. So I'm writing S equal to 0, R equal to 1. Now the next one. Now 1 to 1 transition, everyone. Sir, previous state is 1 and the present state is also 1. Previous state is 1 and present state is also 1. So we can say that 1 to 1 transition is happened in this case. These two states are there in which the 1 to 1 condition is happening. If you look at in these two conditions, sir, you can feel S0, S1. It means S is going to change. But if you follow the R0, R0, it means R is fixed, but S is going to change. So R is fixed, but S is going to change. So this is, and one thing more, excitation table मेरे भाई कसम से बहुत important है. Because excitation, because in the one-off session I am going to discuss about the Mealy and Murray machine cycle. Mealy and Murray, it is a very important, guys, very important. Try to understand, because nowadays the question of the GATE exam, we can expect the question from the state diagram actually. So the Mealy and Murray FSM finite state machine we are going to discuss in the one of the separate session, right? And in those session you can feel, my dear friend, only those students are able to solve and able to design that state machine who has the knowledge of the excitation table. So excitation table और characteristic equation, ये दो तो टिप्स पे होना चाहिए कि कोई नाम भी पूछे ना तो नाम से पहले आपको बताना है कि excitation table SR का क्या है और characteristic equation SR का क्या है, like this. Okay. Yes, Mayur. Now everyone, so how we can remember it, everybody? So समझने के साथ साथ याद भी होना जरूरी है. So everyone, if you want to discuss this one, everyone try to understand. Sir, how we can write? Sir, for the excitation table, if you want to discuss about the excitation table, come on. If you want to discuss or if you have to want to remember that excitation table, we know that Qn and Qn plus 1 is already, we know that 0, 0, 0, 1, 1, 0 and 1, 1. How we can remember about this one? Sir, you can feel it. Sir, it is very simple. 0, 1, 0 cross, 0, 1, 0 cross. 0, 1, 0 cross, 0, 1, 0 cross, like this. But only 0, 1, 0 cross, 0, 1, 0, only those people are able to understand who know it is a 0 to 0, 0 to. जिसको ऐसा नहीं कि इधर तो याद हो गया 0, 1, 0 cross, 0, 1, 0 cross और इधर ठीक ठीक लगा रहे हैं. Mayur, at this particular moment, may be possible if you mail, then it may possible the VSSC location may change. Right, you can exam center में you can change, right? Okay, एक बार मेल कर दीजिए एंड अपनी सिचुएशन को शेयर कर दीजिएगा, डेफिनेटली हो जाएगा, कोई टेंशन नहीं लेना. ओके, सो इट विल बिकम 0, 1, 0 क्रॉस, 0, 1, 0 क्रॉस. इट इज एक्साइटेशन टेबल. कैरेक्टरिस्टिक इक्वेशन S प्लस R बार Qn. कम ऑन, मेरे साथ बोलते भी रहना. कम ऑन, S प्लस R बार Qn. S plus R bar Qn. And now it's time to discuss about the state diagram. Sir, how we can form the state diagram with the help of this? How we can write? For the any flip-flop, if you want to discuss, there will be the two states are given. One is called 0 and the second one is called 1. किसी भी flip-flop के दो ही output हो सकते हैं, या तो 0 या फिर 1. And now my dear friend, now मेरे प्यारे दोस्तों, so the transition will happen like this. Either the transition will goes from 0 to 0. If the transition will goes from 0 to 0, what should be the meaning of this? Sir, S0 R cross. The meaning of this one is S0 R cross. S0 R cross. The next one is called, sir, if the previous state is 0 and next state is 1, it means the transition will happen from 0 to 1. If the transition will happen from 0 to 1, S1 R0. So we can write S1 R0. Now if the transition will happen from 1 to 0, then what should be the S equal to 0, R equal to 1? S equal to 0, R equal to 1. Akhila, good afternoon. I'm fine, Akhila. How are you? Okay. And now then the next condition, if you want 1 to 0, S0. Oh, लिखना ही भूल गया. One to 0 means S0 R cross. And 1 to 1, if you want to discuss, my dear friend, we can say that S cross R0. S cross R0. So everyone try to understand. It means we can say that everyone. So we can say that if you anyhow, everybody, because in the after the sometime we are going to discuss about the hardware also, how we can design the hardware, right? So my dear friend, everybody try to understand what should be the meaning of this. Sir, okay. So this is called nothing, it is just a circuit diagram. If you know the circuit diagram, with the help of the circuit diagram, we are able to form the truth table. If you know the truth table, then with the help of the truth table, we are going to discuss about the characteristic table. If you know the characteristic table, with the help of the characteristic table, we are able to make the characteristic equation. If you know the characteristic table, we are able to make the excitation table. And if you know the excitation table, with the help of the excitation table only, we are able to understand what? And we are able to make the state diagram. So this is the very important, guys. Very important. Okay. Sir, how we are designing the hardware? Hardware designing, I'll give you the concept after the some time. But at this particular moment, we have to remember, sir, 1 to 0, R equal to 1. Phase 1 to 0, 1 to 0. R equal to 1. Yes, correct. ये R1 है. R1. Yes, correct phase. Now, if this point is basically clear to you, and one thing more, everyone try to understand. Always try to understand these 7 point, 1, 2, 6 point, 1, 2, 3, 4, 5 and 6. These things you have to remember. सबको tips पे होना चाहिए चीज. And now everyone, this is called SR flip-flop right now. In the SR flip-flop, we can say that for the 2 input, there will be the 4 states are possible. For the 2 input, there will be the 1, 2, 3, 4 states are possible. But out of these 4 states, oh, okay. Yes, phase, thank you. No issues, Chinmay, parallel ladder is already available into the YouTube. You can watch that session, no issues. Okay, one thing more, everyone. Sir, we know that by the 2 input, the 4 states are possible. By the help of 2 input, you are able to form that 4 state. But my dear friend, out of these 4 states, you are able to utilize only the 3 state. 4 state hai, but we are going to utilize the 3 state. We are not going to utilize the last state. Last state we are not, because it is invalid, right? It does not allow when the both input is equal. It will not allow. So my dear friend, to remove this problem, come on, to remove this problem, we are designed the one more flip-flop. We have designed one more flip-flop that is called JK flip-flop. All 3 condition is same. It will become J. It will become K. Only the last condition here, it is Qn, it is 0, it is 1. Same. We are not going to change. Last state में बस ये हो जाएगा Qn bar. It means whenever the J equal to K equal to 1 is given, we will complement that previous state. That is called JK flip-flop. Sir, how the hardware is basically looking like? My dear friend, I can make the hardware at this particular moment also, but I will give you the designing approach so that you are able to make not only for the JK flip-flop, you are able to design all the flip-flops hardware. But for those, you have to be very passionate and watch the lecture very, very carefully. Okay. Now this point is basically clear. Now we are moving on the next. Dekho. So it means the now that is called JK flip-flop. The one famous question we can expect from the generally in the interview we can expect. Sir, S equal to 0, R equal to. In this case, S equal to 0, R equal to 1. Then it is called reset. Okay. Now everyone try to understand. Now we can say that the very famous interview question we can expect from the JK flip-flop is, what is the full form of the JK flip-flop? Can anybody give me the answer? What is the full form of JK flip-flop? Everyone just respond and give me the answer. What should be the full form? मेरे प्यारे दोस्तों, what is the full form of JK flip-flop? Everyone just respond and give me the answer. Just respond and give me the answer. What is the full form of JK flip-flop? None of the people are responding. Everyone jaldi response kar do beta. What is the full form of JK flip-flop? Okay. बहुत बढ़िया. बहुत से लोग बोलते हैं और lots of people are basically thinking like jump and kill. There is no jump, there is no kill. What is the full form? There is no full form. Yes, Kavya, correct. Sir, there is no full form of JK flip-flop. It is the name of the scientist. That is called Jack Kilby. he used word two letter J and K. So everyone try to understand. If anybody asks what should be the full form of JK flip flop, you have to remember. Yes, Bhanu, correct. Jack jilbe nahi beta, kilbe. Right? So you can remember there is no full form of the JK flip flop. Okay. Okay. Now everyone try to understand. So what should be the truth table, sir? We can discuss the truth circuit diagram later on in the designing part when we are going to discuss. Yes, Sayan. बहुत बढ़िया. So we can discuss everyone. JK flip flop, it is just a circuit symbol of the representation of the JK flip flop. What should be the circuit diagram? If you zoom this part, how it will be looking like? What should be the hardware associated with it? I'll discuss in later on. But at this particular moment, you have to remember only the what? Only the symbol. अंदर का हार्डवेयर भाई बताएंगे अपन, कोई दिक्कत नहीं. Yes, China, correct. Now what should be the everyone? What should be the truth table? For the truth table, if you want to discuss for the J equal to 0, K equal to 0, it is called Qn. Same. These three states are same as the SR flip flop. These three states are basically same as the SR flip flop. And last stage is nothing. When J equal to 1, K equal to 1. We know that in the SR flip flop, it is an invalid condition. In the SR flip flop, it is an invalid condition. But into the JK flip flop, it will be toggle state. Toggle means what? Whatever the previous state is. Come on. Whatever the previous state is, now we are going to reverse that previous state. We are going to change the previous state. So if the previous state is 0, now it will become 1. If the previous state is 1, now it will become 0. Right? So we can say that for J equal to K equal to 1, we can toggle the previous state. That is the condition. Now everyone. Now if this one is basically known to you, how many of you are able to make the characteristic table with the help of the truth table? How many of you? एक बार बता दो बेटा, आप में से कितने लोग हैं जो करेक्टरिस्टिक टेबल की मदद से ट्रुथ टेबल की मदद से करेक्टरिस्टिक टेबल बना सकते हैं? यस चिन्मय, करेक्ट. दिस इज कॉल्ड एवरीवन. सर इफ इट इज अ एसआर सेम एज एसआर फ्लिप फ्लॉप अपार्ट फ्रॉम द लास्ट स्टेट, सो वी कैन से दैट अप टू दिस पोर्शन everything is same as the SR flip flop. Everything is same as the SR flip flop, right? Apart from the last stage, everything is same as the SR flip flop. You can feel J equal to 0, K equal to 0. It is just a condition where S equal to 0, R equal to 0. Me sir, चलिए correct. कॉमल, बहुत ही बढ़िया कॉमल बनाओ. S equal to 0, R equal to K, it is the same. It will hold the previous state. Previous state is 0, present state is 0. Previous state is 1, present state is 1. Like this you have to write. Now, when in these two conditions, and after this we are going to discuss about the race around problem also. Yes, Mayur, रहेगा मेरे भाई. Okay. Now everyone try to understand. बहुत ही बढ़िया सयान, यतेंद्र, excellent. Now for S equal to 0, R, because here K is nothing, it is just a R. J is nothing, it is just a S. यतेंद्र बहुत बढ़िया. So we can say that, sir, when J equal to 0 and K equal to 1, when J equal to 0 and K equal to 1 means, sir, the output should be reset. That's why we have made the output reset. In the last two condition, sir, when J equal to 1, K equal to 0, J equal to 1, K equal to 0, we have to set the output. That's why we have set the output irrespective of the previous state. And the last one, when J equal to 1, K equal to 1, J equal to 1, K equal to 1, sir, we have to toggle the previous state. If the previous state is 0, now it will become 1. If the previous state is 1, now it will become 0. So we have to toggle its previous state. बहुत ही बढ़िया भानु, excellent. भानु प्रकाश, मजा आ गया भाई, बहुत ही बढ़िया. So this one is called nothing, it is just a characteristic equation. Characteristic table. And now by the characteristic table, if you want to make the characteristic equation also, how we can make the characteristic equation? So if you want to make the characteristic equation, then we can say that for the characteristic equation, my dear friend, we have to make the K map and minimize the function. And that function you have to write in the terms of J, K and Qn. So अगर आप लिखोगे, you can feel the Qn plus 1 is nothing, it is just a J, Qn bar plus K bar Qn. We can say that J Qn bar plus K bar Qn is nothing, it is just a characteristic equation. It is called characteristic equation. Yes, Shushma. Now, after the characteristic equation, it is called nothing, it is just a characteristic equation. It is called characteristic equation. Now after the characteristic equation, कॉमल बहुत ही बढ़िया, जे क्यू एन बार प्लस के बार क्यू एन, ये तो रटा होना चाहिए मेरे भाई. अच्छा एस आर का क्या है सर? एस आर एस प्लस आर बार क्यू एन, जेके का जे क्यू एन बार प्लस के बार क्यू एन. वेरी सिंपल. ओके, नाउ द एक्साइटेशन टेबल. Sir, if you want to discuss, yes Suman, that's great Suman. If you want to discuss about the excitation table, how we can write the excitation table, you have to remember one thing more. Sir, अगर excitation table की अगर मैं बात करूं, how we can write the excitation table? Sir, for the excitation table, it is called Qn, it is called Qn plus 1 right now. 0, 0, 0, 1, 1, 0 and 1, 1, we know that. According to that, we have to make the table. इसी की मदद से फिर से already we have discussed into the SR flip flop, like that you have to form. How? Sir, first 0 to 0. 0 to 0 is here also and 0 to 0 is here also. Only these two conditions. J equal to 0, K equal to cross. J equal to 0, K equal to cross. Like this it is happening. J equal to 0, K equal to cross. Now, next one 0 to 1. 0 to 1, 0 to 1, it is 0 to 1. 0 to 1, it is 0 to 1. In these two conditions you can feel J1, J1. But K0, K1. It means it is a fix that J equal to 1, it is not a J XOR K. Chini, it is not a J XOR K. If you want to write J XOR K, it means J K bar plus J bar K. But it is not like that, na? So it is not a XOR, J XOR K, it is something else. J Qn bar plus K bar Qn. And it is already a minimized expression. Okay. Now, so you can say that J equal to 1, but K is not fixed. K may be 0, may be 1. So J is fixed, but K may be 0, may be 1. So don't care. Like this you have to design. अगर अगला बना देते हो, everyone, if you want to write like next, what should be the next? Sir, 1 to 0. If you want to make the 1 to 0 means nothing. Where is 1 to 0? Sir, here it is 1 to 0. Sir, 1 to 1. It means it is fixed that K is 1. But J may be 0, may be 1. So J is the don't care, K is 1. Okay, so we can write, we can say that 0 to 1 or 1 to 0. 1 to 0, J cross and K1. Like this you have to make the table. And now my dear friend, we know that already. What should be the SR flip-flop excitation table? Come on. कोई दिक्कत नहीं चीनी, सॉरी वॉरी की कोई दिक्कत नहीं यार. कुछ मैं आपसे सीखता हूँ, कुछ आप मुझसे सीखते हो. Something you are just getting from me and something I am getting from you. So there is no sorry, it is a bi-directional. Okay. Now one thing more, everyone. For the SR flip-flop, if you want to discuss how it will be looking like for the SR flip-flop, S plus R bar Qn. वो तो equation था. Excitation table, if you want to write the SR flip-flop, 0, 1, 0 cross, 0, 1, 0 cross. Yes. And for this one, if you want to write 0, 1 cross, cross, 0, 1 cross, cross. Like this you have to remember. You can feel there will be the symmetricity. 0, 1 क्रॉस क्रॉस 0, 1 क्रॉस क्रॉस. पर ये सब काम तभी आएगा जब इधर 0 से 0, 0 to 1, 1 to 0 एंड 1 to 1 हो. ऐसा नहीं कि इधर तो याद हो गया, अरे बहुत सिंपल है 0, 1, 0 क्रॉस 0, 1 और इधर ठीक ठीक लगा रहे हैं अपने हिसाब से, देने वाला भाव दे रहे. So you have to remember. Now the excitation table. So excitation table we have remembered. Now we are going to discuss about the state diagram. Sir, how we can make the state? Any flip-flop having the two states only, either 0 or 1. Any flip-flop having the two states. So we can write the two state. It is called 0. It is called 0. It is called 1. Any state having, any flip-flop having the two states, 0 and 1. And the transition will happen like first 0 to 0. Sir, 0 to 0 transition will happen. What should be the meaning of this? 0 to 0 when J0 K cross. So I'm writing J0 K cross. And after that, in the one of the session, my dear friend, I will give you this state diagram. And with the state diagram, we will make the hardware. That is called FSM, finite state. बताऊंगा, वो भी बनाना बताऊंगा, बहुत ही आसान होता है. Very simple it is, right? But for that, you have to maintain the continuity and watch the class regularly. Sometime जो 2 दिन में मेरे साथ हुआ है कि नहीं क्लास ले पाया, फ्यूचर में हम इस चीज़ को अवॉइड करेंगे, मेरी तरफ से भी और आपकी तरफ से भी. Right? Okay. Now, the next one, if you want to discuss, sir, 0 to 1 transition. So everyone, 0 to transition means it is called like this. Sir, 0 to 1 means what? J1 K cross. So I'm writing J1 K cross. J1 K cross. Now we are going to discuss the next one. 1 to 0. Everyone, 1 to 0. 1 to 0 means nothing, it is just a 1 to 0 means what? J cross K1. So I'm writing J cross K1. And the next state 1 to 1, if you want to discuss the transition, how the transition will happen, 1 to 1 is basically given. 1 to 1, J cross K0. J cross K0. Like this type of situation, you have to remember how from the excitation table we are making the state diagram. This is a very simple. Now, what happened when J equal to K equal to 1 is, J equal to K equal to 1 is basically given, then you have to make the invalid condition. When J equal to K equal to 1 is given, it is called invalid condition. Saturday, that is Bhanu, thank you Bhanu, thank you. Okay. Now everyone try to understand. Ki sir, if J equal to 1, K equal to 1, we have to invalid the previous state. We have to invalidate the previous state. Oh, sorry, invalid will happen in the SR flip-flop. In the JK flip-flop, whenever J equal to K equal to 1 is applied, it will toggle its previous state. Now, my dear friend, for this discussion, I am going to discuss the few points. One note you can write. D flip-flop थोड़ी देर बाद देखेंगे. चलो पहले D flip-flop ही देख लेते हैं. After that, I am going to discuss, after the D flip-flop and T flip-flop, we are going to discuss about what should be the meaning of a race around problem, right? But first, we'll discuss about the D flip-flop. Very simple. It will take hardly 10 minutes to discuss, right? Okay. So D flip-flop, what should it means for the SR flip-flop? Again, for the SR flip-flop, two things is most important: characteristic equation and excitation table. For the SR flip-flop, what is the characteristic equation? S plus R bar Qn. S plus R bar Qn is the characteristic equation for the SR flip-flop. Okay. What should be the excitation table of the SR flip-flop? 0, 1, 0 cross, 0, 1, 0 cross. Okay. For the JK flip-flop, what is the characteristic equation? J Qn bar plus K bar Qn. It is a characteristic equation. And what should be the excitation table? 0, 1 cross cross, 0, 1 cross cross. Like this it will be happen. बहुत ही बढ़िया. Now we are going to discuss about the D flip-flop. Everyone, D flip-flop is also called data flip-flop. Data flip-flop, delay flip-flop, transparent flip-flop, whatever you can use. It is called data flip-flop. Somewhere in the sum of the book, I have heard the name delay flip-flop also. But mostly they are using the word data flip-flop, right? Delay flip-flop. So everyone try to understand what should be the meaning. It means we can say that, sir, it is also known as delay flip-flop or transparent flip-flop or data flip-flop, right? Okay, sir, what should be the beauty of the D flip-flop? In the D flip-flop, there will be the only one input terminal. Come on. In the D flip-flop, there will be the only one input terminal. And in those input terminal, whatever you can apply the input, along with the clock, it will comes into the output. That is the beauty of the D flip-flop. Yes, Kamal, correct. So we can say that in the D flip-flop, whatever the input is applied, it will directly comes into the output along with the clock. That's why we can say that. Yes, Yarava Balu, I am regularly taking the class, but yesterday I haven't taken the class due to some network issue. That's why for the compensation, I have taken the class into the daytime. Right? Okay. So again, in the D flip-flop, only the one input terminal is there. And if whatever you can apply the input, it will go into the output. If you apply 0, it will comes into the output. If you apply 1, that 1 comes into the output. So my dear friend, we can say that it is just a symbol. Whatever you can apply the output, it will comes into the output, but it comes into the output only when the clock is applied. Only when the clock is applied, then only it will be happen. That is the beauty of the D flip-flop. Okay. And that's why generally in the registers, we are going to discuss about the registers also. Generally in our syllabus, there will be the shift register is given. SISO, serial input, serial output shift register, parallel input, serial output shift register, parallel serial input, parallel output shift register, CISO, CIPO, PISO, PIPO, parallel input, parallel output shift register. So everyone try to understand. So registers we are going to design with the help of D flip-flop only, right? Okay. Truth table. Sir, what should be we have already discussed that it is called data flip-flop. So whatever you can apply the input, it will comes into the output. So if you apply the 0, that present state you will take you will get the present state only just because of what input. Right? So you can apply the 0, output 0, 1, 1 comes into the output. Now, if this one is basically cleared, then we are moving the characteristic table. We know that, sir, Qn plus 1 equal to D. It means whatever the D you can apply, it will comes into this condition. It does not have any relation with the previous state. Apply 0, Katak 0. Apply 1, tatak 1, like this. So 0 to 0, 0 to 0, 1 to 1, 1 to 1. It is like this. Very simple. Okay. Sir, now we can say that, sir, what should be the truth table? What should be the characteristic table? For the characteristic table, if you want to discuss, my dear friend, we can write very easily. Sir, we know that D and Qn plus 1 is same. So Qn plus 1 is nothing, it is just a D. You can take it also. D Qn bar plus, because for this, if you are making the equation, D Qn bar plus D Qn. D you will take the common. So it will become nothing, Qn plus 1 equal to D. और D और Qn plus 1 सेम ही तो है. बहुत ही बढ़िया सुषमा, बहुत ही बढ़िया. सुषमा लक्ष्यकार, बहुत ही बढ़िया. Now after the characteristic equation, we have to discuss about the excitation table. For the excitation table, we know that previous and present state is known to you. It means Qn and Qn plus 1 is known quantity for us. And we do not have any idea about the input. So the formation of the table for the input in the terms of previous and present state, right? And by the analysis of the previous and present state. So we can say that everyone, sir, क्या बना रहे हो? Qn plus 1 and D से. If A equal to B, then B also equal to A. अरे जब शक्तिमान ही गंगाधर है, तो गंगाधर भी तो शक्तिमान है ना? So we can write Qn plus 1 equal to D. So D is also equal to Qn plus 1. So this 0 will become 0. This will become 1. This will become 0. And this will become 1. Same Qn plus 1 you have to copy into the D. Okay. Now the state diagram, we know that according, if the 0 to 0 transition is happened, the D equal to 0. 0 to 0, D equal to, like this we have formed the table. We have made the equation. Because if excitation table known to you, then we are able to design the state diagram also in very simply. In very simple. Yes, Shirsha, correct. Sushma, correct. Chinay, correct. Chinmay, correct. बहुत ही बढ़िया. Sir, D flip-flop circuit. Chinay, just give me few minutes. After that, we are going to discuss about the designing part. And the designing part, we are able to design all the circuits hardware. All the flip-flops hardware, right? Okay. Now there will be the one thing also that is called T flip-flop. There will be the one thing also, there will be the T flip-flop. Yes, Bhanu Prakash. T flip-flop means T resemble with the word that is called toggle. It means it is also just like a D flip-flop. It is also just like a D flip-flop, but there will be the one thing. What is that? Ki sir, whenever in the input 0 is connected, come on, whenever in the input the 0 is connected, then it will hold the previous state. Whenever in the input the 0 is connected, it will hold the previous state. But whenever in the input you will connect 1, it will toggle its previous state. If the previous state is 0, the present state will become 1. If the present state is 1, then if the previous state is 1, then present state will become 0. If the previous state is Qn, the present state, that is Qn plus 1 bar, Qn plus 1 is become Qn bar. इसका मतलब जो भी होगा उसका उल्टा हो जाएगा. Whatever the previous state is, that will be the toggle, but it will be happen when t equal to 1 is connected and clock is applied, then only it will be happen. So at this particular moment, I am just giving you the symbol, and after the some time I will zoom it. I will show you the hardware. Yes, Shushma, modification of JK, definitely. Everything is the modification of JK, Shushma. That's why the Shushma, very good word. JK is also called universal flip-flop. Because if you closely observe the truth table of the JK flip-flop, you can feel every flip-flop, the truth table is inside the truth table of the JK flip-flop. Okay. Now truth table. Sir, we already know that whenever the input is 0, it will hold the previous state. Whatever the previous state is, it will hold the previous state. But whenever the t equal to 1 is happen, it will toggle its previous state. So it will become nothing, it is just a Qn bar. So it will become Qn bar, very simple. Okay, now we are moving on the next. So it is called symbol, it is called truth table. Now the next one is called a characteristic table. For the characteristic table, if you want to discuss, we know that the previous state and present state. And we know the input and we know the previous state, that is Qn. Bhanu, already have given my mail ID is personal mail ID, it is official mail ID. Okay. Okay. If you want to discuss about, now if you want to discuss, it is called T, it is called 0. Now if you want to discuss how we can make the table, everybody, if the input is 0, we can say that if the input is 0 and 0 is given, then we can say that, sir, if the input is 0 in these two conditions, and these two conditions the input is 1, whenever the input is 0, it will hold the previous state. So previous state is 0, so it will become 0. Again input is 0, so previous state is 0, so and input is 1, so it will become 1. It will become 1. Yes. I will discuss, Ravi, after this truth table we are going to discuss it. Okay. Now this point is basically clear to you. Then we are moving. Sir, what happened when the s t equal to 1, 1 is basically given? If t equal to 1, 1 is given, then we can say that, everyone try to understand. If the t equal to 1 is given, it will toggle its previous state. It will toggle its previous state means nothing. It is just a, if 0, it will become 1. And if this one is 1, it will become 0. So everyone try to understand what should be the meaning. Whenever the input t is 0, it will toggle its previous state. Sorry, 0, it will hold the previous state. And if input is 1, it will toggle its previous state. You have to remember these points only. Okay, after that, yes, Chinik, bahut badhiya. Characteristic equation. Sir, if you want to discuss about the characteristic equation, then Qn plus 1 is nothing. It is just a, you can feel, T bar Qn plus T Qn bar. So we can write T XOR Qn. So we can write T XOR Qn. It is called T XOR Qn. Okay. T XOR Qn. It is called characteristic equation. Now we are moving on the next, right? Now we are going to discuss the next. Sir, excitation table. We know that key, sir, if the previous and present state is changed, the meaning of this only when the t equal to 1 is applied. So if the previous state and the present state is 0, if the previous state and the present state is 0, it means it must be 0, because whenever you will apply the input as a 0, whenever you will apply the input as a 0, then only it will be happen, the previous and present state will become the same. If the previous and present state is changed, meaning itself is you are connecting the input as a 1. You have connected the input as a 1. So my dear friend, again it is changed, definitely 1. It is changed, definitely 1. Same, previous also 1, present also 1. And now if you want to discuss about the excitation table, with the help of this you can make. No issues. How many of you understood up to this portion? Just write down yes or no. Okay, everyone. Just take it. Okay. Now, my dear friend, everyone try to understand. JK flip-flop suffers from the problem of race around. We have already, you guys are also already aware about the race around problem. Now, what should be the meaning of the race around problem? So, everyone try to understand. For the race around problem, if you want to discuss, I just want to make the table first, right? In the JK, everyone, in the JK flip-flop, whenever the J equal to K equal to 1 is applied, everyone, whenever the J equal to K equal to 1 is applied to the JK flip-flop, I'm just going to discuss about the race around problem. I'm going to discuss about the race around problem, everyone. You have to remember one thing. Sir, what should be the circuit diagram? We'll discuss it, wait. But at this particular moment, I just want to write, it is called J and it is called K. It is called J, it is called K. It is called Qn, it is called Qn bar. And now I'm taking the level triggered JK flip-flop. Actually, it is I'm just taking the level sensitive, right? I know that the flip-flop is the edge sensitive, but I'm just considering as a level sensitive, right? And now in the level sensitive, JK latch, you can use the word, it's better. Whenever the J equal to K equal to 1 is applied and clock is given, when J equal to K equal to 1 is applied and the clock is given, then the output of the flip-flop swing or changed or toggle so many times. The output of the flip-flop toggles so many times. The output of the flip-flop toggles so many times. Sir, how it will be happen? I'm going to discuss. यस सुषमा, अब देखो कैसे होता बेटा. सपोज आई एम टेकिंग द क्लॉक, एवरीवन, सपोज आई एम टेकिंग द क्लॉक. Suppose it is the clock. It is called clock, right? Now if this one is clock, so I'm writing this one is called time period of this clock. This is called time period of this clock, T clock. And now one thing more I want to share. This one is called nothing, it is just a pulse width. Up to this portion is called pulse width. This one is called pulse width. Okay, now everyone try to understand. Now everyone, sir, if we have applied for this JK flip-flop, everyone, we have applied. Suppose the previous state we know that whenever the J equal to K equal to 1 applies, and I am writing this one is nothing, it is just a level sensitive. Level sensitive means in this particular sensitive, in this particular range, the flip-flop will works. In this particular range, the flip-flop will operate. Flip-flop को ऐसा फील होगा कि मुझे क्लॉक मिला है, and I have to change their previous state. Why we have to change the previous state? Because J equal to K equal to 1 is connected. Now if I am saying कि sir, suppose if this one having the previous state is 0, Qn is 0. Now यहां तक ये 0 है. I'm just making the output of the Qn plus 1. Right? Now this one is 0. Now my dear friend, if this one is 0, now whenever the J equal to K equal to 1 applied, and here you can feel the clock is also applied. यहीं से clock apply होना शुरू हो गया है. So if the clock is applied, it means इस flip flop को feel होगा कि अरे मुझे तो clock मिला है. I have to change my state. But every flip flop having some propagation delay. It will require some time to change from 0 to 1. And that propagation delay is associated with this flip flop. So my dear friend, now this flip flop want to make the output or they want to change their previous state, that is from 0 to 1, but it required some time to change. Even the clock is connected due to the propagation delay. So this 0 will go into the 1. And this is called nothing, it is just a propagation delay of flip-flop. This is called propagation delay of flip-flop. And one thing more I want to share in the evening also. Today there will be the 2 session. Not 2 session, actually there will be the 3 session. One session is the motivational session in the at 10 o'clock. At 9 o'clock, a very famous topic we are going to discuss, that is called hold time or setup time. In 2020 also the one question came from this, that is called 13 nanosecond, a very famous question. Alright, so must attend the session, evening session right now. It is called top EDFF. Now, so after that it will become 0 to 1, and now if it will become 0 to 1, again the clock is connected and J equal to K को तो मैंने set करके रखा ही है. So my dear friend, again this flip flop will feel कि अरे मुझे तो अभी भी clock मिला है. I have also connected, now also the one clock is basically connected, so I have to change the previous state. Okay, so it will become 1 to 0, 1 to 0. It will become 1 to 0. Now it will become 1 to 0. Now again जैसे ही 0 हुआ उसको फिर से फील हुआ, क्योंकि because in this particular duration that will be works as a clock. So this will become 0 to 1, and this is the propagation delay, because every flip-flop has some propagation delay. So it will become 0 to 1. Again it will become 1 to 0. Again it will become 0 to 1. Again it has to change, and now the clock is missed, so it has to maintain. It means, my dear friend, you can feel, again मैं repeat कर रहा हूँ, what should be the meaning of this? कि sir, whenever the latch or whenever it is a level sensitive and J equal to K equal to 1 is connected, then within the duration of the pulse width, come on, then within the duration of the pulse width, the output of the flip-flop toggles so many times. How many times the output of the flip-flop will change or toggle, it will depends upon the 2 things. One is called propagation, pulse width. Pulse width को और बड़ा कर दो, the more time it will be 10 10 10 10 10 will happen. More time the 10 10 10 10 will happen. right? And one thing more, it will also depends upon the propagation delay of the flip-flop. It will also depends upon the propagation delay of the flip-flop. Now sir, I got to know कि what is the meaning of the race around problem. Komal sir, explain once more. Okay Komal, try to understand. मयूर सर, आपने मेल का, मयूर भाई मैं बता दूं, 2 दिन से मैं क्लासेज जो आपके ले रहा था वो उदयपुर से लेता हूँ, राजस्थान से, और 2 दिन से ड्यू टू द सम वर्क आई हैव टू रीच टू द दिल्ली, सो मैं अभी दिल्ली आया हुआ हूँ और अपना काम कंप्लीट करवाऊंगा. अभी स्टूडियो से ही क्लास ले रहा हूँ. कल से जो क्लास चलेगी, कल इवनिंग से सारी क्लास आपकी प्रॉपर तरीके से चलेगी कोमल भाई, और मैं रिस्पॉन्स भी कर पाऊंगा. मयूर, मैं रिस्पॉन्स भी कर पाऊंगा आपके मेल का. मुझे बस 1-2 दिन का टाइम और दे दो, राइट? बिकॉज अभी लास्ट 3-4 दिन जो है बहुत हेक्टिक निकला है, राइट? ओके, now everyone, now we are going to discuss, sir, again I am repeating what should be the race around problem. Everybody try to understand कि sir, whenever the flip flop or whenever the latch are level sensitive, whenever the JK latch is the level sensitive, then everyone, no issues, no shot, Mayur, no, कोई दिक्कत नहीं भाई. Whenever the flip flop or latches are the level sensitive and J equal to K equal to 1 is applied, then within the duration of the pulse width, the output of the flip-flop toggle so many times. The output of the flip-flop toggle change so many times during the pulse width. And at the end of the pulse width, the output of the flip-flop will either settle at 1 or settle at 0, irrespective of the whatever the previous state is. क्या था उससे कोई लेना देना, किसी पे भी सेट हो जाएगा. बहुत बार टुक 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 होगा और किसी एक पे सेट हो जाएगा. This is called, आपस में ही रेस कर रहा है. It will be racing with itself, right? So that first it will become 0, after that, after the propagation delay, it will become 1, after that it will become 0, after that it will become 1. So many times it will changing. This is called race around problem, because this entire duration is works as a clock for this flip-flop. And of course the J equal to K equal to is connected, right? So many times it will be changed, and at the end it will be maybe settle at 1 or maybe settle at 0. This is called propagation. This is called problem. And this problem is called nothing, it is just called nothing. It is called what? It is called race around problem. Now the question arises, sir, how we can avoid this race around problem? So my dear friend, the race around problem we are going to discuss into the evening session. मैं थोड़ा evening session के अंदर मैं discuss कर लेता हूँ और जो काम के लिए आए हैं वो भी निपटा देता हूँ. So in the evening I will discuss about the first, if anybody is facing the problem, sir, I am not getting this it, so no issues, in the evening in a very comfortable manner, and in the practical example also I'll give you, regarding to that you can understand what should be the meaning of race around. मैं एक छोटा सा example से समझाऊंगा, एक story से I will connect the race around problem, and what should be the solution of that race around problem, how we can design the hardware, and what should be the meaning of the hold time and latch time, setup time. I will discuss into the evening at 9 o'clock. Ravi, very good question. That's why generally I'm using the word latch. If you remember, if you'll go through the back and if you'll watch this video again, generally I'm referring the word latch, I'm not referring the word flip-flop. Because if it is as triggered, as sensitive, then only in this duration it will change. So this type of problem is not happening. Are you getting my point, Ravi? No issues. In the evening I will discuss in very much of detail about this, right? Evening में session को discuss करते हैं, right? Till that, thank you very much. All the very best at 9 o'clock. And I need more count, so that my dear friend, please convey along, convey to all of your friends, because today's night we are going to discuss about the designing part, which is very very important. So अपने सारे दोस्तों को बता दीजिएगा, और एक बहुत critical question आपसे discuss करूंगा, which already I have faced during the ISRO interview. Right? ISRO interview का एक question मैं आप लोगों के सामने share करूंगा into the night. Okay. No, Chini, latches are the level sensitive. Flip-flop is the S. Right? So thank you very much. All the very best. See you tomorrow, tonight at 9 o'clock. Till that, thank you very much. Thank you.